Hello.
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 Hey, how are you guys?
Great.
I'm going to kick everybody else in the neighborhood off the internet. So hold on a second here. We share the internet with a rental cottage next.
Hey, Anna.
Hello, Jane. I'm dog sitting this dog today. He's so cute. I won't talk about it.
Where's that?
It's at my house.
Oh.
Yeah.
Okay. Our hosts aren't quite here yet.
Yeah, I just arrived.
Oh,
Oh,
hi.
hello.
Hello. I have to rename myself and I will make everybody co-hosts. You guys are all co-hosts, right?
Right, and Brenda, who's not quite here yet.
That's fine. I will take care of that. We have multiple co-hosts, which is great.
Well, I'm going, and do you, Anna or Jane, do you have the All About Arsenic video? Can you cue that up in case my internet doesn't allow me to do that? Because we had that little 10-minute video as part of our presentation.
Yes. In small doses.
In small doses, right. And let me get.
There's something about making sure that you allow your computer audio to play when you do the video.
Oh, yeah.
I wanted to just
Well, see, my computer audio sucks. So.
Right. No, but whoever's going to play the video, just so that we know that we can, the meeting doesn't start for 10 minutes. So if you wanted to like practice that.
Oh, okay, cool. Let me.
It's just a good idea because Chris is my tech guru, and of course he's running a different meeting.
Okay, so let me. It's going to share a screen here. Hold on. Oh, this looks different. We did practice this last night, but.
Oh, I'm going to pause the recording.
Okay, yep.
There we go.
Okay, so welcome, first session of the morning. And it is citizen science, engaging students in real research. What I've got, I see there's more than two people here. I've got two people written down, Brenda Mitchell from Bow High School and Mary Wright from Kearsarge High School. Mary holds a BS in biology from Bates and an MS in zoology from the University of Maine and has been teaching the high school and college level for over 25 years. She currently teaches at Kearsarge Regional High School. Brenda Mitchell graduated from UC Berkeley in microbiology and has been a teacher for over 30 years, 20 of them at Bow High School. They are both part of the All About Arsenic Science Education Partnership grant program through the Mount Desert Island Biological Laboratory and Dartmouth College. Anna Farrell and Jane Disney, PhD, who are also here, work at MDI Biological Lab and oversee the All About Arsenic grant. I love the title. Jane began her career as a high school biology teacher.
Okay.
So.
Okay, well, thank you all for coming. I'm going to attempt to share a screen a minute and talk a little bit about citizen science in general, and then the project that the four of us are involved in as a group. Anna and Jane are the experts really in the particular project, and I hope they will feel free to chime in, especially if I say something incorrect. Now, let's see here. All right.
It's working.
Don't jinx it. Okay, so in our particular project, we were using a public health issue to involve students in research, and then using this research to meet curriculum goals with regards to data analysis and community outreach. Here's a little brief bio about our folks, which we've already kind of gone through. Citizen science involves all the things that we try to teach our students: the observing, the questioning, the planning, the analyzing, and communicating. It just does it in some slightly different ways. What is it? I mean, technically, if you're to Google a definition, you'll come up with one of the two here: research that is conducted in whole or in part by amateur scientists. And it can also be public participation in scientific research. Lot of questions like, why would you take the time to do this? And why have students participate in it? Tons and tons of really good ideas that we're going to be going over and will come up during this talk. But it is helping create engagement in science. It certainly gets the community involved in scientific projects and builds competency in science. And I think it's important, particularly in this day and age, to stress that science is not just for scientists. And I don't know if anybody has any other comments. Any of my other presenters have comments about this one. Okay. As we've said before, obviously, any involvement in a research project has development of critical thinking skills, and there are a lot of Common Core and next generation standards. I put some at the end of the presentation, and I want to say right off the bat that a lot of them are actually math standards, but there are obviously Common Core and next gen standards for that can be met. But where we see some of the huge benefits, it empowers students to impact their communities. And I cannot stress this enough. A little bit later, we have some stories to tell about the project in our schools, but parents were very impressed that students were able to explain to them the implications of their water study that were done on their home wells, which is what this project was about. Jane, this was some, I'm going to throw this over to you because you've been doing citizen science with teachers for so long.
Mm-hmm. Well, the previous slide had a picture of students making a presentation to their community about the results of their well water testing. And they did this in the context of citizen science in that they were collecting data that was going to be used not only by scientists interested in the distribution of arsenic in wells in the two states, Maine and New Hampshire, but also because the data that they were collecting had immediate interest for the community and for Center for Disease Control, as well as in New Hampshire for the Department of Environmental Services. So part of this project, the students collect their water from their home faucets, bring it in, and it's tested at Dartmouth, which is our partner in this project as well. They have a trace element analysis core that tests the samples. And so this is real scientific data, real world data that is telling the students something about the public health and the potential risk to their community members. So it's this impact on the community that takes collecting data as a citizen scientist to what we call action. So this is really a data to action project. It's funded through the Science, help me, Anna, through the Science Partnership
Award
from National Institutes of Health. And I think you've been hearing Mary tell you lots of reasons why citizen science is a positive thing in K-12 classrooms. But here I've circled the two that really relate to this concept of community impact, in that students begin to think outside of themselves when they're engaged in these kinds of projects. It's not, you know, what do I need to learn? What do I need to learn to pass the test? What do I need to learn to pass this grade level to achieve this standard? But, you know, what do I need to learn to help my community? And the citizen science connecting students to the world around them, this is, you know, contaminated well water is a global issue. And we're helping students in this project understand that as we work out protocols and we figure out how to communicate with our parents, neighbors, community members, and as we all figure out how to interpret our data and make it available to others, we're setting a standard, we're establishing a model that can translate to other communities too. And ultimately, that's what we hope will happen. So what a big deal for students to be involved at this level with science and to have so much context for their learning. I think when, and this kind of scientific engagement provides relevance and context for students, I think their incentive is huge to learn. And Mary and Brenda are on the front lines with their students and can really tell you the impact it's had on their students. And then they'll tell you more as we go on, I'm sure.
Thank you. Citizen science has a huge history. When I was looking into this, some of the earliest, some of the earliest examples are John Holmes in the 1600s started a process in the American colonies to collect and analyze weather data. Again, his goal was to see patterns in the data so that weather events could be predicted. So this was the start of that. A lot of detailed observations, collected them, tried to analyze them. Another one of my favorites was Mary Anning of Devon, England. She is the young woman about whom the little ditty "She Sails by the Seashore" is about. Got it through. She and her brother collected shells and sold them to tourists, but they also, as the cliffs or the area of Devon, in that area of Devon, they began to find dinosaur bones and coprolites, and she's the one that figured out that these funny little structures were in fact fossilized dung. She discovered the Ichthyosaurus and actually forged relationships with the scientists at the British Museum to the point where they actually gave her a stipend for some of her work. There are numerous examples of amateur astronomers making important discoveries, almost too many to mention. There are other ones like John Audubon, and the Audubon Society does this as well. So some other organizations that promote citizen science projects, NOAA, California Academy of Science, I've already mentioned Audubon, the Planetary Society, EPA, NIH, National Institutes for Environmental Health Sciences, NSF, and of course NASA. So they're there, and what's new and kind of interesting is modern technology has really expanded this. And in our case, one platform that helps citizen science, it's called Anecdata. And now I apologize, this is a screenshot, and I'm going to be using screenshots then live streaming of them, because I am told every 4 or 5 minutes that I have unstable internet. So I thought this was a better way to go. So if you go to Anecdata, and you can see their homepage, and it's all about collecting observations of our changing world. And there are hundreds, there are lots and lots of, not 202 projects at the time that I took this screenshot. So some examples of projects on this site, and I just picked a couple. One's called CNET. It's a Seabird Ecological Assessment Network. And they are using seabirds as an indicator of health of the marine ecosystem. And this is a very simple project. Participants agree to walk a section of beach 1 or 2 times a month and record any dead seabirds that they might find. So if you were to look at CNET on Anecdata, you'll see this kind of a screen. It talks about the project. It has the oops, get my pointer here. It talks about the project. It has project goals, what the participants do, who's running it. There's a button here to join. There's buttons once you join to add observations. So it's a pretty easy way to participate in citizen science. Another one that I found which was kind of cool was Silent Earth. And do you have a favorite urban, suburban, or rural place you think are really quiet? This project lets you measure the sound levels and enter your data on a world map for others to share. And again, I thought this was sort of a fun one. But this is our page, the All About Arsenic page with MDI Biological Laboratories. And it was started in 2018. You'll see that Jane and Anna, and Kate, who's not here today, are running the project. There's places for downloading the full data set, and it talks about the goals and what participants do. So again, the All About Arsenic project is using this as an organizational platform for us. Now, a little background. I'm going to attempt to show you guys a short video about arsenic, video put out by Dartmouth College about arsenic in water. Whoops. I may have to. It doesn't. Okay, let me stop sharing for a moment and see if I can get this. All right.
So Brenda,
Yep.
I'm wondering if you are set to share this from your screen as well, because it's very pixelated from Mary's computer.
Arsenic has been known to be acutely toxic
Is
for
this-
millennia.
Is this video very pixelated too?
If you take it at
What does everybody
100
think?
parts per million
Good.
in the water,
Fine.
then it will certainly
Okay.
kill you moderately quickly. But what was not known until fairly recently is continuous use of very low doses can be very bad. And that means continuous is daily ingestion. You know, arsenic's a very common element in the Earth's crust. It's a number 20 or something like that. And the question is, how do you get it inside? And it's coming mostly through water.
The reason that's important, for example, in New England is maybe 1/4 of all the people's wells in New England have levels of arsenic that we might think of as not being safe.
We have estimated that about 2.3 million people in New England use private wells as their source of drinking water. And in some states, like Maine and New Hampshire, that's about 40% of the population.
New Hampshire law does not require water testing at private homes, nor quantity requirements at private wells.
Low-dose arsenic exposure has been associated with skin cancer, bladder cancer, particularly in smokers, and possibly lung cancer.
That's why it's particularly important for private homeowners with wells to test their wells periodically and to take action to protect their family. In 2001, EPA revised their drinking water standard for arsenic to 10 parts per billion. And that was done after many months and years of extensive testing and research.
The drinking water standard in the United States for the levels that we used to think were safe was 50 parts per billion, which sounds like a really tiny number, and it is. It's 50 micrograms, which is a millionth of a gram, for every liter of water. So it's a really, really tiny amount. And yet, we now know from epidemiology studies that that level is not safe, that if you drink that level for a lifetime, your disease risk is pretty substantial.
With the previous arsenic drinking water standard of 50 parts per billion, it was thought that the cancer risk was as high as 1 in 100, meaning 1 in 100 people drinking arsenic at 50 parts per billion would develop cancer.
Normally for man-made contaminants, the acceptable risk rate for pesticides, herbicides, fuels, industrial solvents is 1 in a million.
We now have laboratory studies and some emerging epidemiology studies that suggest that 10 is not safe either, that we're seeing health effects at as low as 10 parts per billion.
So we're really interested in looking at these low levels and what's happening. So sort of asking the question of how low is low enough for an appropriate drinking water standard.
Overwhelmingly, the evidence that we have suggests that the arsenic we see in groundwater originates from natural sources in the minerals and the rocks of the region. Apparently, there's 2 main factors that control whether arsenic ends up in your groundwater, and that's having some arsenic in the rocks as a source, but also having the right geochemical conditions. And in New Hampshire, that equates to having water that's relatively high pH and water with relatively little dissolved oxygen. Those 2 factors together result in high arsenic concentrations in water.
In the world today, in Asia alone, about 100 to 120 million people suffer from arsenic-related illnesses.
How arsenic causes disease is the big $64,000 question. Nobody really knows the answer to this. What we do know is that arsenic doesn't behave like any other chemical that we know.
My research focuses on the effects of low-dose arsenic exposure on the immune system, particularly the immune system within the lung. What we've done is we've developed a mouse model in which we expose mice to arsenic in their drinking water at 100 parts per billion for 5 weeks. 100 parts per billion is not an uncommon level of arsenic to find in areas of New England, such as New Hampshire and Maine. Following that exposure, we infected the mice with a sublethal dose of influenza A, an H1N1 strain of flu. And what we found was that the mice exposed to arsenic had an increased susceptibility to infection, and they also had an increased severity of infection, resulting in a severe morbidity observed in those arsenic-exposed mice. In theory, there would be a dose threshold in which we would expect no effects for arsenic exposure. The problem is that we don't really understand what that dose would be. We've certainly seen effects following arsenic exposure at 10 ppb or even lower.
In my laboratory, we've seen effects on endocrine disruption and some other endpoints that we measure at below 1 part per billion. So now we're talking about parts per trillion, which is a hard number to even think about.
The question remains as to whether or not these effects are biological effects or toxicological effects, meaning do they have an adverse outcome on human health or not?
And so the issue is one to educate the homeowner on in terms of the importance of having a comprehensive water quality test.
I go to the state, I get a little decanter free, and the tests cost $10 to $15.
The liquid is sprayed into the instrument and it goes into the inductively coupled plasma, which is a hot ionized gas. It's 7,000 degrees, which is hotter than the surface of the sun. So the sample basically is desolvated, you lose all the water, and the molecules are broken up into the chemical elements. And those elements are extracted into the mass spectrometer, and then the mass spectrometer basically counts the atoms of any particular element. So we determine the element by its unique mass, and we count the number of atoms in that sample. And that's how they determine concentration.
It takes maybe 2 weeks to get the results back. It's a pretty easy process, in and out. There are various ways to remediate arsenic, and they're pretty inexpensive for a household like ours.
There are 2 different sizes of water treatment devices. One is called Whole House and would deal with approximately 200 gallons of water each day. The other is called Point of Use and would only deal with the water that one would consume each day.
It's not thought that dermal exposure, such as you would get in the shower, is such an immediate concern when compared to ingestion through the drinking water.
We actually got ours at Sears and had a plumber come and put it in underneath the sink. So I think you can put them in yourself, though.
At the USGS in New Hampshire, our primary responsibility is to provide impartial science information on the nation's water resources. We know from our studies that certain parts of the state have 30% of wells where we see arsenic concentrations exceeding 10. By zooming in and looking more closely at specific geology, we see some places where every other well has arsenic greater than 10.
If arsenic is in a city water supply, the city takes care of it, generally, and at least tells you if there's a problem. If you have your own water in your own well, the city doesn't have to do that. So, in fact, it's your own responsibility to take care and figure out what that arsenic concentration is.
So really the bottom line is that everybody has to test their well. There's no predictive power. It doesn't matter whether your neighbor does or doesn't have arsenic. Each well is individual and has to be tested individually.
Okay, this, as I said, that gives context, and this is something that we actually show this the students, and it's part of our kickoff. Let me get back to our screen here for a second.
And of course, for Bo, one of the highlights is the family that's shown there is our community members, and most people are familiar with them.
Okay. So let's get back to what our students do. So we ask the student, we teach them how to collect the samples from the kitchen sink, and how to register their samples on Anecdata, because they're going to be be able to look up their results on that same site. That process can be a little tricky. There are a lot of mistakes that happen. I had the kids last year. We sent them home during a 2-week window, and then we registered them as a group in class. I'm not quite sure how I'm going to be doing it this year, depending on how much is in person and how much is remote at our school. We have a senior project requirement at our high school, and I did have the help of a advanced chemistry student senior who helped organize some of the kits that the kids took home. There's a side project which I haven't been as involved with, where some schools collected a second sample that was sent to the University of Maine for they were growing zebrafish in these water samples and were looking for adverse outcomes in their development. They bring the samples back. They eventually get mailed out for testing. We actually send them to Anna, who makes sure that we haven't screwed up too terribly. And once the results are there, the data sets are uploaded onto Tuva platform, where the data can be explored.
And if I can just jump in,
Sure.
in order to make this a little less black boxy, what I do in my classroom is we also test water samples. So We can't, of course, we don't have a mass spec, but we can look at some of the basic water qualities. So we can look at the pH, and we can look at the dissolved solids. And we do as much of that as we can with their own sample and with foul water that I've made up so that they can understand a little bit more in a hands-on way about water quality.
Now, some of you probably are familiar with Tuva. This data set is also uploaded into this online platform, which makes it easy to visualize, explore, and interpret the data. Now, I don't mean this to be a Tuva tutorial. There are Tuva tutorials actually out there that you can use, but and go through, but just to get an idea of what you can do with the data and how you can use the data to answer student questions. And again, I did this as screenshots as opposed to running you through this live. When you first access data on Tuva, this is the whole 1,873 data points.
A mess.
Yeah, it's a mess. So each dot is a data point, and its position on this screen is random. But you'll notice over on the left-hand side, we've got these case cards here. And a data points are cases in Tuva, and each case has a case card with all the information about that sample. Now, my screenshot only goes down part way. If I were to scroll this down, it would have the results of all sorts of heavy metals that were in the sample and other aspects of water quality. And they call this information, each one is called an attribute. And it's these attributes that you can drag and place on the X and Y axis. And also, if you want to have something color coded, you can put it over here on the far right hand side. So you can actually look at 3 attributes visually at a time.
And if you haven't used Tuva before, it's so intuitive for kids because it's the drag and drop, and they can switch the X and Y axes, they can switch the type of graph, and it takes literally, you punch the button and it's done. So it's very quick. And
unless you're living in, or unless you're in Liberty, Maine. So anyway, right now, in this particular example, I organized the data by amount of arsenic in micrograms on the left and the SEPA school name. So these are all the schools in Maine and New Hampshire who are involved in the project. And here is a plot of their data. Now this is a huge, huge data set, 1,873 data points, might be a bit much. So I filtered it down using this little button here that looks like a funnel. I like to imagine that there's filter paper in there. And selected Bow High School and Kearsarge High School, my school and Brenda's school, and to take a look at a smaller data set. And here they are. This is Bow here on, whoops, let me get my pointer back. This is Bow over here, and here's Kearsarge. Now, Bow has a lot more data points. I think they were more successful in getting some back, and they've run it for this data.
2 years.
2 years, yeah. And this is 1 year for Kearsarge. Now, I did put a color type here so that we could take a look at the question, does the type of well matter? And we have drilled wells. The blue here is drilled and deeper than 50 feet, driven wells, dug wells, I don't know, other or public. And so when you look at this, and I also added a line here. Now in the state of New Hampshire, anything above 5 micrograms is considered to be unsafe. Now, there's a lot of research that indicates that no level of arsenic is safe, but this is what the state of New Hampshire has said. So I drew that line on the data set just to see what points are above it. And in the case of Kearsarge, it looks like the problem wells tend to be these drilled wells. Public water supply does not seem to be a problem there, which is as you would expect. Now let's take a look at both schools. I said I just focused in on this one mainly because it was a little clearer. And yeah, there was that line there that I added. Okay, so now I've included Bow's data, and they have, well, I'll let Brenda talk about Bow's data, I guess.
Well, our data, Bow is historically within New Hampshire a high arsenic region. And part of that may be the drilled wells going deeper into the aquifer. It's definitely the geology of what's going on. And I'll talk a little more later about the fact that despite this, we've had a very hard time as a community getting people to test their wells. Part of it is a I don't want to know mentality, and part of it is a concern with how this will affect real estate values. But in any case, we've gotten more testing through this project than the Water Committee was able to get in 10 years, and we've done that in 2 years. The Water Committee is over the moon. So you can see we've got some really, really, really high points on there. And a lot of our low points are because those are people who have already remediated.
So Brenda sort of already answered this, but if you were working with kids, so why does Bow have higher levels than Kearsarge? Some possible answers. Bow has done more testing, has a better grasp on the problem. And there are geological differences between the two areas, even though they are relatively close. We, we're probably 30 or 40 miles away from one another along 89, I think.
Maybe not even that.
Maybe not even that. So one of the ways that you could do this is start exploring is to look at the data by zip code. And that's what I did here. And it does look like there are certain zip code, whoops. Sorry about that. There are certain zip codes that are more problematic, like here's one, than say over here. And the green dots are Bow, came to Bow High School, the samples.
Mm-hmm.
Now, the reason I put the red arrow on that one dot, that's probably a staff member from Bow who lives in the Kearsarge district, and I think that might be on the other way around too. So zip code is probably better for looking at geological. There's also longitude and latitude that you can put into here, but when I did it, it was kind of a complicated site. So why isn't the data collected and reported by address? And this, Brenda mentioned that people are extremely concerned that if they are found to have, if it's publicly known that they have high arsenic, they won't be able to sell their house, and privacy issues. So there is the designers of the grant, and maybe Anna or Jane could talk about this. There is a approximate longitude and latitude, but it's not, it's made so that it's not the exact longitude and latitude so that you couldn't identify a house.
Right.
And I think rightly so, the decision was it was more important to inform people if they have a problem than to have lots of reasons why they shouldn't test. And
yeah, I had a family who refused to test last year because their house was up for sale. And I could not get them to understand that no one would have access to this except themselves. And a lot of people these days are asking when they buy a house for a water test. So at least they could remediate before they sold it if the person inquired, and they wouldn't go for it.
Okay, so here's some sort of anecdotal stories, and Brenda, go ahead.
Okay, so the first year we did this, a parent wrote us an email, and I don't have the exact email, but the gist of her email was that she had really not paid a lot of attention to the project. She'd signed off permissions, whatever, and then the results came back, and they had quite an elevated reading of arsenic, and she was shocked because they have younger children. So they put on a point of use remediation and retested when we tested again, and we're thrilled to find that it worked. And they sent this very nice letter saying they would have never tested nor found out the results if it hadn't been for this project. As we saw before, we have staff that have been asked to be included in testing. I always offer it to them. People want to test their camps. Now, this has gone up on the out-of-district people in the last year after we got back our first results. People got much more concerned. And in fact, people in our school community will contact me and say, I'm selling my house. I want to get my water tested. Should I, and what do I do? Which I'm going to skip down to the I don't want to know. I mentioned that earlier. A lot of people in our community have a false idea that they need to do whole house water treatment and that this is going to cost them $10,000. And one of our big things after the first year of realizing that, because people walked past us, didn't want to pick up their free water sample, and said, no, I don't really want to know. I don't have the money to fix it. I don't want to know then. Was to say, the point of use, $200. You can get a zero water filter for $30. This is not something that's going to break your budget. You can definitely afford to remediate. And my last story is an ironic story of having become more aware of water quality. I discovered during the year, 2 years ago, in January, I was getting, every time I tried to make silver nitrate solutions, I was getting precipitate. And at first it was a student doing it, and she thought she did something wrong, and then another teacher did it, and then I did it. And
Lost you, Brenda.
I can't wait to hear.
were quite high.
Brenda, we lost you. It cut out.
I'm sorry. At what point did I die?
The important part about what was causing the seasonal.
All right. So we have this, and you can tell my internet is not good today. Of course, this morning it's not good. The water was testing very high for chlorine. And it turns out that the salt from our roads in the winter, from treating the salt, gets into our well, which causes our water to be caustic. So we end up with not only more chlorine, because when I told the school, they're like, well, what's the big deal? Chlorine, it'll just kill more germs. It's not a big deal. It's also eroding the pipes. It causes lead to be released because the lead is in solder, so you get higher amounts of lead. And of course, it makes some chemistry experiments unable to work because we get precipitation instead of solutions. So we actually ended up applying for a American Chemical Society grant to get ourselves a a water distiller, and I have to deionize the water and then distill it basically between December and March in order to have decent water.
Wow. Now, at Kearsarge, this past year was our first year, and I'm going to say it wasn't as successful, partially for COVID, but because we got our samples back, the results back in December, and I was thinking, all right, we get back from February break, that's a good time to start, and that's when all hell broke loose. So, and we went remote and et cetera. But the families with high levels were contacted by MDI scientists, and I'll in a minute let Jane and Anna talk about that process, when any levels of measured minerals or elements were unsafe. And at least 3 families contacted did institute filtration systems for faucets and kitchens. One also put them in the bathroom sink because they were concerned that kiddos were coming in the middle of the night drinking that water. And as I said before, the families were very impressed at their children's ability to, and I was working with high school students, to explain the risks and remediation process to them because it was something that we had gone over. And they thought it was kind of cool that it was something that they had done as sort of a science project actually has the potential to improve health for their families. So I don't know, Jane and Anna, you want to talk about the what you do when you see high levels in a water sample?
Sure. So that's my job. I coordinate all the samples, and I get a report back from Dartmouth, and then we input all the data into ANIC data. And then for any family that has a high level for any of the 14 contaminants that we test for, I send them a personal letter to their home and include resources on what to do and next steps for them. So we wanted to make sure, we're not sure that families are always checking on their results when they're ready. So we wanted to really make sure that families who had excess contaminants were aware of it. Oh, and I see a question in the chat. Can anyone do analysis on the collected data? Yes, it's downloadable to anyone on ANIC data. The All About Arsenic project is publicly available. And like Mary alluded to earlier, that's one of the reasons that we have made sure that nobody can pinpoint exactly where a data point comes from, because that isn't necessary. But you can do kind of larger scale geographic analysis if you wanted to do that.
And that was something that I'd hoped to do, some GIS. We have a GIS class that just started up at our high school, and there was hope that they would be able to do something with the data, and maybe they will this year. So that was kind of cool. Again, I put, this is my sort of last slide, were the citizen science projects that meet NGSS standards, and here are a few that they could fit under. But as I said earlier, most of them are in fact mathematics standards too. So what Brenda and I were wondering if you all were, if we go into breakout groups at this point to discuss what topics might be of interest to you and your students, and maybe people with better internet than me can look on ANIC data to see if there's any existing project that might interest your students.
And also remember that you can create your own citizen science project. And if you don't want your students to collect data, they can also participate by analyzing data that's already out there. That's one of the joys of having the data out there, is you can look at real data.
So you want to start breakout rooms now?
That would be awesome.
And we have till what time? And that's sort of the questions that we didn't get to.
That's true.
Before we go into breakout rooms, I'm going to post the link to the discussion notes so that we can record the discussion, the breakout rooms, but sometimes there are comments or links that come up in the chat and we can post them there. And then each breakout room has a page.
Cool.
Create more, if I need to create more pages, I'll do that. But you do need to open the link before you go to the breakout room, because it will be lost otherwise. And instead of getting the link, I accidentally grabbed the file name, which isn't going to help us. Give me 1 second.
Is it the one they shared earlier?
Yes, but if you came in after I posted it, you can't see that.
You won't see it
Again.
Also, I should give a shout out too that Brenda and I also have collaborators with local colleges and universities. And in my case, my scientist collaborator that helped with the project was at Colby Sawyer College. And what was very nice there is his students came and gave a number of presentations to my students. Now, again, I'm not sure how we would do that this year if we're remote, but this happened, I want to say January of this year, past year, where his environmental science students who had been involved in the project at Colby Sawyer came and presented. So it was a very nice collaboration.
Yes, I had a collaboration with someone at Keene. I'm now switching to the Colby Sawyer one. And the Keene one, what was nice, she was a biology teacher, but we had a bunch of her undergrads come in and do a presentation on undergrad research at college. And the students were absolutely rapt. I mean, seriously, I invited all of my chemistry students, all levels, and we did it in the auditorium, and they were completely silent during the presentation and all abuzz about it afterwards, the idea that in 2 years they could be doing real research.
And that's part of this All About Arsenic project design. All of our teachers are partnered with scientists who work collaboratively with the teachers and the students in carrying out these citizen science projects.
We've talked with the professor from Colby Sawyer, and this year, if we are all distant when we're doing the project, we were talking about working on a newsletter and having his students assigned as like editors, overseers to a small group of my students, so that they could have the perspective of someone who's actually very close in age to them, but is also more advanced in their studies.
I don't know, Jane or Anna, could you talk about what the University of Maine extension of the project was? Because that's something that's kind of cool too.
The Crowd the Tap, or?
No, the sample that had to be frozen and then sent off to the University of Maine.
Yeah, so it's interesting just how many other scientists now have found out about this project and have gotten interested and want the high school and middle school students to partner with them as well, collecting duplicate samples at times that they can use in their research. So the University of Maine professor Nishad Jayasundara, he is studying the impacts of well water contaminants on a zebrafish model. He's very interested in effects on mitochondria and energy, and he's using a physical movement assay in zebrafish larvae to try to develop some sort of a metric for how toxic the water is. And then he's able to look at all of the well water test results and see if they correlate with changes in fish behavior after exposure to well water. And they have some really wonderful preliminary results. They saw that fish that had hyperactive movements were the ones that were treated with well water high in arsenic, and the well water samples that were high in uranium or lead led to hypoactivity in the fish. So it looks like fish movement can be a measure of what's going on in the water. So that's an interesting study. And the students are, again, being citizen scientists and contributing to that research. And then we have some research that popped up at College of the Atlantic. There's a geology professor there, Sarah Hall, that's been interested in seasonality of arsenic in wells, and her students are going back to wells in different seasons, and they're finding that in a dry season, the arsenic can be much higher than it is in a wet season. It gets concentrated in the wells. And so those students are generating, those college students are generating a whole new data set. Watch for this, because this is going to show up on tuvalabs.com as well. It's going to be just another and different and more complex data set for students to consider is what happens season to season.
Wow.
And on and on. Yep.
I was just going to say, Tuva Labs, if you haven't used it, there is a free access of Tuva Labs. They have not only the graphing ability, and you can upload a certain number of data sets to it to graph it through them, but they also have a bunch of presets.
Oh, Brenda cut out here.
Tuva Labs has a lot of other activities that students can do to learn basic data literacy skills.
Yeah, there's one with using the periodic table and other things too. So there's
Yes.
We all set then?
Yes. I think
Okay.
we're set for breakout rooms.
Okay, how, what's the timing? How long do you want them to last?
How about 15 minutes?
Okay.
All right. Does everyone have the link for the discussion document in case you want to record conversation topics there? Okay. Brenda, you're in charge, or Catherine, you're in charge. Can you send us to the breakout rooms?
Yep, I will do that.
Thank you.
Breakout rooms. Logins. Open all rooms.
And it looks like no one else is back yet, but they're coming. We'll just continue our discussion.
Yeah, we recreated it.
So lots of good things. I mean, we had a lot of really good sources and things I didn't know about. Definitely things to continue. And that's why we set up the pages the way we did. So that, you know, it's, you don't have to try and figure out where to go or make sure it gets to everybody. It's all right in the right folder. So.
Well, it's cool that you can see what everybody else talked about as well. Yeah. I like that.
I actually learned that from AP Teach, which is a discussion group that sort of sprung up late in March, early in April to help. And the focus initially was on helping AP chemistry teachers adapt to the modified exam and the online exam that the College Board chose. And they did a similar thing where there'd be sometimes a short presentation, and then we'd do breakout rooms and we'd have discussion points and keep track of it, and then come back and sort of do a wrap up. I'm like, oh, I know how to run my sessions. That's how I learned how to do, you know, breakout rooms and make it usable for the kids. So that was really helpful. And they presented on Monday, actually. So. And then we had a break. Everyone needs to get up and move around a little bit. And, you're welcome to stay for any other sessions that you want to, Anna. I think you have the links to all those Zoom meetings. So
yeah, thank you so much. I'm really impressed with the organization of the whole workshop.
Chris really spearheaded all of that. I worked out the main conference schedule, but he's the one who really made the online documents and organized that. We had lots of people going back and forth.
It's been very smooth. It's been so easy to navigate. Like, you would think you guys have been doing it this way forever. It's been great.
Well, you know, the thing is, part of it, the reason why it worked is because this is how we organize our conferences when we meet in person. You know, plenary sessions, separate discussions coming back. So we really wanted to maintain that structure to it. We didn't want it to be a webinar where people just speak at you and there's no opportunity to interact with other people. That was really important to us as we put this together.
Yeah, your breakout room should be closing down then.
Yeah, everyone should be coming back soon.
Yep. Okay. Are you in the main room right now?
We're in the main room.
Oh, okay.
And you are too, I think, yes?
Yeah, okay. I thought I wasn't somehow got in another breakout room.
No, you can shut all the breakout rooms. You have the power, Kat.
I did.
You did. You did it. Do you feel powerful now? You know, you have the magic touch.
Yeah, people should be coming back. They are.
It looks like the other groups had some really involved conversations. Like breakout room 2 has lots of notes.
Oh, we had a great guy taking notes. That's why.
Yeah, no, that's awesome. That's what we want. Right?
And a lot of the discussion was, how do we not always look at poisons? How do we not always scare people? Is there a way to make this a more positive experience? So, right. Because we want kids to walk away saying, we can do something about this, not, oh my God, we're all going to die.
Yeah, that's a really good point.
How about the other rooms? Did people have any just big things they want to share?
In our room, we talked about some different resources for community, getting students involved, like different sites that offer community science projects that you can jump into, or different resources just in general. It was a little more of a general discussion, but it was really helpful because I have no background in this and never knew how to get started in it. So we sort of talked about that, which was really good.
It is really good. Any other insights? Well, I want to thank all of you for coming, and for Anna and Jane for being here, and hopefully you guys met them. They are actually, if you're from Maine, they're pretty famous. I discovered there's a place I go every year on vacation, and I just mentioned to the caretaker of this cottage, right? Oh, I was at this thing at MDI. He goes, "Did you meet Jane Disney?"
Everybody
I
knows
said,
Jane Disney.
Yeah. And I was like, yeah. And he goes, "She's great. She saved our bay."
We had famous people here. Do the paparazzi follow you around all the time?
Yes. Yes, I think they do. So if nothing else, you got to be in her presence for a while. Now you can tell people, "I met Jane."
We're like, yes, I know her.
And you'll be famous amongst lobstermen. And
There you go. Yes, famous among lobstermen. And for the rest of you, check out the Anecdata site and see what projects are there. And remember, there are lots of other.
Oh, she went again.
Again, it's whenever she gets the important things.
Right.
All right. Well, and thank you guys for being such a good audience.
All right. It was a really, really interesting presentation. I really enjoyed it.
Oh, thank you.
Thank you.
All right. See you around.
See you
Good
around.
job,
Bye.
Linda and
Our
Mary.
next sessions are at 11:15, so take your break and walk around a little bit.
Oh, good plan. Okay.
Okay.
All right.
Bye, everybody.
Bye.